Good morning, children. Continue the class today. So that is continuation of permutations and combinations. Some write today first. Today now write some formulas about this continuation of the lesson. So if there are n persons in a row, I'm writing formulas first. There are n persons in a row. The number of ways of selecting two consecutive persons. Then the number of ways of selecting. First one, two consecutive persons. Two consecutive persons is n minus 1 ways. Similarly, second one, three consecutive persons. Three consecutive persons is n minus 2 ways. That is third one. Four consecutive persons are there. Four consecutive persons is n minus 3 ways. And so on, we can generalize it that r persons are there, r consecutive persons is n minus of r minus 1 ways. So just we will see some example from this. Suppose three persons are there, we sitting like this. How many ways are they are the three persons are in a row. So then therefore the number of ways of selecting two consecutive persons means, let us take this one, and this is the one way, and this is the another way. So how many ways totally? That first work 1, second work 2. So how many ways? If three persons are there, the number of ways of selection is consecutive terms is 2 ways. Suppose four persons are there. Four persons means, let us take 1, 2, 3, 4. This is the one way, and another way is this is, and this is the another way. So number of trials are here, work done, that is work 1, this is work 2, this is work 3. If the four persons are in a row, so therefore the number of ways of selecting consecutive persons in three ways. If four persons are there, we can select three ways. Similarly, three persons are there, we can select two persons, two ways. So nothing but there are n persons in a row, then the number of ways of selecting two consecutive persons is always one value lesser, that is n minus 1 ways. Three consecutive persons is n minus 2 ways, and four consecutive persons is nothing but n minus 3 ways. Similarly, r consecutive persons is selecting is n minus of r minus 1 ways. This is the general example. So that is general concept. Similarly, second formula. If there are n persons in a row, if there are n persons in a row, there are n persons in a row, then the next person, then for the next person, to sit in. How many ways? Nothing but n plus 1 place. N plus 1 places. How means if a person sit in A is there, so that is B, it is the one way. Another way is, so how many ways totally? So this is can be done in 2 ways. So what is meaning that if there is n persons in a row, then for the next person to sit in n plus 1 ways. This is the one way and this is the another way. So it can sit in 2 ways. So similarly, if 3 persons are there, 3 persons means how many ways we can select, that is, suppose 3 persons are there. So 3 persons means we can select in as, suppose A here. So this is the one way, second way. This is the B here. How many ways? 1, 2, 3 ways. So that is 2 places. Similarly like that. So generally that we can say that it has n plus 1 places. So this is the simple one. If there is n persons in a row, then for the next person to sit in n plus 1 ways. If next person sit in ABC are there, how many ways? We can get 4 places. If three persons are there, 2 persons are there, so you can get the next person to sit is 3 places. 3 numbers are there, he can get as a 4 places. Example is like this. If 2 persons A and B are there, how many places we can get? That is 3 places. First place, second place, third place. 3 places. If 2 persons are there. Suppose example 1, example 2. 3 persons are there. 3 persons means suppose A, B and then C. How many ways? This is the first way, second way, third way and fourth way. Therefore, and for 3 persons in a row, so then for the next person to sit in the next, how many places means n plus 1. 3 places means we get 4 places. 2 persons are there means how many get? 2 places. 3 places. 2 persons are in a sit in a row, we get 1, 2, 3 places. If 3 persons are there, you get 4 places. In that way, so 1 person is there, you can get 2 places. So it with the way of 2 ways to select in the order. In the same way, next formula I am writing in the next page. The number of permutations of n distinct things the number of ways of n distinct things taken are at a time so that first point, a particular thing is always included is a particular thing is always included is r into n minus 1 p r minus 1. Second point, a particular thing is always excluded. There is 2 parts we will take. So first one is included part and excluded part. Always excluded is, we get one part, one place is over, then you get from r things, that is denoted by n minus 1 pr. Therefore, n minus 1 pr plus r into n minus 1 pr minus 1 equal to, we denoted by npr. That is nothing but the number of terms is n. By taking r at a time, that is becomes to NPR. So that is the simple proof is there. So next to go to the next similar questions. Previously we can completed the next continuation of this lesson. Just please make a note. If you want to see the proof, then I will write. Okay, that is the formula for this one. Next, go to the next lesson. Continuation of the exercise problems. Exercise 5.1. Continuation exercise 5.1. Sixth problem now. Find the number of permutations of n dissimilar things taken 3 at a time. Find the number of permutations. The number of permutations of 4 dissimilar things. Of 4 dissimilar things taken 3 at a time. So when the question is given that total number of terms are 4, we are selecting 3 at a time. How many ways you can complete this one is asking. So it is now already we have the formula. So if there are n things are there, we are selecting r at a time, that is denoted by NPR. In the same way here, the number of total things are 4. By taking 3 at a time, it is denoted by NPR. So here n equal to 4 and r equal to 3. So then we write here N4P3. That's all. This is the question. We are arranging the number of permutations from the 4 dissimilar things taken 3 at a time, that is denoted by 4P3. So that solution is we have to write here the number of permutations of 4 dissimilar things taken 3 at a time is 4P3. That is nothing but 4 into 3 into 2. That is 24 ways. That's all. This is the ways question. How many things are there? Totally 4 things taken 3 at a time. So let it be in the form NPR. NPR nothing but 4P3 here. That's all. This is the question number 6. Question number 7. A man has 4 sons and there are 5 schools within his reach. In how many ways can he admit his sons in the schools so that no two of them will be in the same school? So a man has four sons, and five schools within his reach. Within his reach. In how many ways? In how many ways can he admit his sons? Can he admit his sons in the school? In the school, so that no two of them, no two of them will be in the same school. Will be in the same school. So number of students are 4 here and schools are 5. So the condition is given that if anyone goes to the school, admit his son in the same school, the condition is no two of them will be in the same school. So that is nothing but the number of ways of admitting the four sons and two into 5 schools. If no two of them will be in the same school, nothing but denoted by so general 5p4. How will you means just you see how many sons are there? 4 sons. And here 5 schools are there. So boy 1, boy 2, suppose let it be boy 3 and boy 4. Schools nothing but school 1, school 2, school 3, school 4, school 5. First person is admitting the school means he has to go. The number of ways are, how many are there totally? 5 ways. And the person is over. Then go to the second person. So that is one of the choice is over. Suppose S1 choices will be there. So and next go to the B2 has how many choices is to join the school is 4 ways. And similarly third person will go to the ways of nulling, that is 2. And next to fourth person we have to go to the school is 2 ways only. So that is way we can write as 5p4. 5p4 nothing but the simplified value is nothing but 120. So this is the very common general thing. So just you write as a simple way in the word form. So that is let it be in the form rough idea. This is so that is how many ways the first person go to the choice are number of ways of arranging in the admission to the school is 5 choices. And second person go to the school is 4 choice. One choice will be over and next choice to join the school is 4 ways. And the third by go to the choice is 3 ways. And the similarly 4 by is 2 ways only. So this is the number of ways of selecting admit his sons in the school. So that is right here the number of ways of selecting ways of permuting or admit his sons in the school. No two of them will be in the same school. That is 5p4. 5p4 nothing but 5 4 3 2 1. That is so this is the simple thing Nana. Write even own words also. Just I am writing simple thing. So that is number of boys are 5 and go to the choice of 2. Sons is 4. Number of sons is a man has 4 sons and number of schools is 5. So the first persons to go to the number of arrangement admissions are 5, and then go to the second person choice has 4 choices, and similarly third by goes to choice is 3 choice, and fourth person is 2, so that is denoted by 5 4 3 2, nothing but it is denoted by 5p4. In the same, that is the value is 120. So that is the way how to write all those calculations and total all these terms. So next go to the next question. Question number 8. Question number 8. If there are 25 railway stations on the railway line, how many single second class tickets must be printed so as to enable a passenger to travel one station to another? So there are, how many stations are there? 25 railway stations are there. If there are 25 railway stations on a railway line, on a railway line, how many second class tickets, how many second class tickets must be printed, so as to enable a passenger travel one station to another, one station to another. Just now the formula will be, we are learned, that is number of stations are, how many stations are there? 25 railway station on the railway line. So the person has to go, passenger to travel is one station to another. This is the one way. So first person, the person has to, number of choices, firstly 25 choice will be there, and then go to the, this is the one way. Similarly next second and third, and third and fourth, this is the one way, and fourth and fifth, that is the one way, and sixth one, that is also one way. Similarly go to up to 25. So remaining how many you get? 24, nothing but 25 p2. So that is the answer. So simple, you have to just by using the formula, that is if there are n stations in row, in there are n part in, just now we have completed, there is n places on the row. So the number of ways of selecting two consecutive persons, just now we have completed n minus 1. That is also in the same way. Here also write in that condition should be applied here. So that is the number of ways, the number of stations on a railway line equal to 25. Therefore, the number of single second class tickets must be printed so as to enable passenger to travel one station to another is, so the number are required, the number of ways equal to, that is nothing but 25 into 24 ways, nothing but we have the right as 25 p2. This is the value 600. So there is how first to travel first one place, that is 25 ways, 25 stations are there, means how many arrangements will be taken as 25 arrangements. One places to another place means total how many we have the consecutive terms. So that is denoted by n minus 1 ways. So that is 25 into 24. So that is 25 p2. So that is the answer. So question number 9. In similarly, the question is, if there are in a class there are 30 students, In a class, there are 30 students. On the New Year day, on the New Year day, every student posts a greeting card. Every student posts a greeting card to all his or her friends. To all his or her friends. Find the total number of greeting cards posted by them. Find the total number of greeting cards posted by them. So therefore number of persons here 30 persons. Therefore the total number of greeting cards posted by every student to all his or classmates is, if a greeting card giving means there are choice, the number of ways of arrangement is any 2 persons out of 30. So it can be done in 30 P2 ways. Therefore the number of ways of greeting cards is denoted by 30 students are there. Out of 30 students, they are giving to student post a greeting card out of 2 persons, 2 persons arrangement. So if I are to giving the greeting card to all his friends, that is meaning that classmates, it is denoted by 30 P2. Number of persons is 30 and giving each other. So that should be done in 30 into 29 ways. 30 into 29 nothing but 30 P2 ways. So this is the answer. That is 870. 30 into 29, that is 870 ways. In the same way, the next question is given, 10th question. Question number 10. Find the number of ways of arranging the letters of the word triangle. Find the number of ways of arranging the letters of the word. Arranging the letters of the word triangle. So that the relative positions so that the relative positions of the vowels and consonants of the vowels and consonants are not disturbed. Are not disturbed. So the given in the given word triangle, so the number of ways of arranging the letters of the word triangle, what is asking, the number of relative positions. That means that it can be arranged in vowels in the place of vowels and consonants as in the place of consonants only. So here we have the given word triangle has number of vowels are 3 are there, number of consonants are 5. Therefore, it must be done in, if 3 vowels can be arrangement in the 3 vowels interchange, just only interchanging by, suppose vowels are I, A, E is there. First arrangement is I with I. that is the one first arrangement. If it is go through by A, second arrangement. If it is E, so that is the third arrangement. So it can be done in starting with I, starting with A, and starting with E. So it can be done in number of ways. Number of vowels can be done in 3 factorial ways, and 5 consonants can be arranged in their relative positions, means 5 consonants are there, so it can be done in 5 factorial ways. Therefore, the requirement of the total requirement arrangements are 3 factorial into 5 factorial. There is don't disturbing the places. Oval should be in the place of ovals only, we have to arrange. So it can be done in 3 factorial. Why? Because the number of vowels are 3. So it can be done in 3 factorial ways. And the number of consonants are 5. So it can be placed within the relative positions, means consonants can be arranged only with consonants only. It can be done in 5 factorial ways. So required arrangements are 3 factorial into 5 factorial. This both operation yesterday we learned by multiplication theorem. This both operation work 1 and work 2 and means we do not add, only multiplication. That is the answer. So that is the solution is in the given word triangle has in the given word triangle has 3 vowels, that is I comma A comma E, and 4 consonants, 4 consonants, that is remaining, that is T, R, N, G, L. Since the relative positions, since the relative positions are not disturbed, means are not disturbed means the three vowels can be arranged in the relative positions in how many ways? 3 factorial ways. Similarly, 5 consonants in 5 factorial ways. Therefore, the number of arrangements, number of ways, the vowels and consonants are not disturbed in their relative positions is 3 factorial into 5 factorial, that is 6 into 120, that is equal to nothing but 720 ways. So the relative position do not disturb means vowels can be arranged in vowels place only and consonants place only by consonants only. So the relative position should not be disturbed. That is why the how many vowels in the question, that is triangle word, that is 3 vowels. So the 3 vowels can be arranged in the vowels places. So that is in the form 3 factorial ways. And the 5 consonants can be done in 5 factorial ways. So both operation work 1 and work 2, work 2. So that can be nothing but by using the multiplication law. So that is 3 factorial into 5 factorial, that is 720 ways. This is the question number 10. Then go to the question number 11. Find the number of ways of arranging the letters of the word Monday so that no vowel occupies even place. Find the number of ways of arranging. Find the number of ways of arranging. Find the number of ways of arranging the letters of the word. The letters of the word Monday so that no vowel occupies even place. This is the question number 11. So that is, and the given word Monday has how many vowels has we have to check once. So how many vowels means two vowels, that is A and O, and consonants means remaining M and DY. So there are how many even number of even places, how many are there? Three even places, and odd places also three odd places. But in the question it is given, since no vowel in the occupies in the even place, that should be filled by three odd places. So should not be filled with even places means we have to fill up by odd places. How many odd places are there? Three. So number of vowels are 2. So this can be done in how many ways? Nothing but 3p2 ways. And the remaining 4 consonants are there. So the consonants can be filled in the remaining 4 places in 4 factorial ways. So that is nothing but answer is 3p2 into 4 factorial. So that is nothing but 4p, 3p2 nothing but 6. 4 factorial nothing but 24. 24 into 6, that is 144. So we have to write all those. Just I am giving some idea with rough work. That is Monday. Monday means number of vowels are A comma O, that is 2 vowels. And consonants are M and DY is there. So that is 4 vowels. So number of even odd ante how 1, 2, 3, 4, 5, 6. So that is nothing but how many even places are there? Even places are 3, and similarly obviously we get odd places also 3. But in the question is given no vowel occupies even place. Vowel should not be in the even place. So that is must be filled with vowels with odd places only. So how many odd places are there? 3. So 3 odd places. Number of letters are A comma O, that is 2. This can be arranged in 3p2 ways. This is the first case. And the second case, if the first vowels placement is over, arrangement is over, then go to the consonants. How many consonants are there? They are different. So nothing but out of 4 consonants can be done in 4 factorial ways. So the answer is the continuation both are there means continuity is there, and and means the keyword is and means we can arrange the letters of the word is 3p2 into 4 factorial ways. The condition should be applied here. In the how many number of ways of arranging letters of the word Monday. Monday means how many even places are there? 3. Odd places are 3. But in the question is given that no vowel occupies the even place. So this should be filled with by odd places. So it should not be in the form of oval place, nothing but it should be filled with odd places. So that is also 3 places are there. So by 3 places we can arrange the vowels in 3p2 ways. Then go to the next step, which is second case is the remaining places should be M and DY. This can be 4 different letters. So these 4 different letters can be permuted in 4 factorial ways. By fundamental principle of counting means multiplication rule. This work and this work. So it can be multiplied 3p2 into 4 factorial. This is the rough idea about the question. So that is write as to total part. So that is Solution. The given word Monday has two vowels. There are two vowels, four consonants, battery, four consonants in the given word in Monday. Since no vowels, since no vowel occupies even place, so the two vowels can be arranged in odd places, in odd places 3p2 ways, and the remaining the four consonants can be filled in remaining four places in 4 factorial ways. Therefore, the number of arrangements is the number of ways are 3p2 into 4 factorial, that is 6 into 24. 6 into 24, nothing but 144 ways. This is the rough idea. So write in all those. There are two vowels and four consonants in the word in Monday given word, that is given word. Since no vowel occupies in the even place means the two vowels can be arranged in odd places in 3p2 ways, and the four consonants can be filled with the remaining four places, so that is in 4 factorial ways. So therefore the number of ways are 3p2 into 4 factorial, that is 144 ways. So all of you